हेलो एवरीवन। आप सभी का स्वागत है इलेक्ट्रॉन फ्लो अकेडमी में। तो टुडेज आवर टॉपिक इज अबाउट एवरेज वैल्यू। So average value is the very important topic of the EC circuits. So the meaning of the value in the EC circuit is related to the average of all the instantaneous values of the quantity over a one cycle. So here the topic is related to the alternating currents waveform. So here we can see that this is your alternating current like that. So this is your x-axis showing the time, and this is your y-axis. For example, we are talking about the current. So in the alternating current waveforms, basically we need to calculate the average value. Okay, so basically the alternating current waveforms are two types. First one is the symmetrical, and second one is the unsymmetrical. Okay, unsymmetrical. So this is the representation of the symmetrical waveform. So for symmetrical EC quantities, the positive half cycle is exactly identical to the negative half of the cycle. So therefore, the average value over a complete cycle, which is completed here at the pi instant, this is your sorry 2 pi instant, this is your pi. So which is completed at the 2 pi. So the average value of the symmetrical waveform is of one cycle is equal to 0. Okay, so this is the meaning of the average value is here. And another waveform which is known as the unsymmetrical. So here for the unsymmetrical AC quantities or AC waves, the average is determined for only positive half cycle. Okay. So however, for the unsymmetrical wave, average is determined over a complete cycle. For finding average values, basically there are two type of the methods. So first method, which is known as the mid-ordinate method. Okay, and another topic or another method which is known as the analytical method. So firstly, we are discussing about the mid-ordinate method. So in this method, generally, or this method is generally used when the equation of AC waveform is not known. Used when equation of AC wave is not known. Okay. So basically, in order to determine the average value, the complete waveform is divided into n number of intervals like that. For example, this is your x-axis showing the time, and this is y-axis showing the current. So here, what we have done in order to determine the average value, divide the time base t into n equal parts of t upon n order. Okay, or duration. Okay, so larger the value of the n, better is approximation of the average value. So here let us consider like that this is the I1 area, this is I2 like that, and this one is the IN. So basically the mid-ordinate method shows us the value of the I average like this divided by total intervals. Okay, so this is the main equation which gives us the average value. Okay, so here we can see that the average value is equal to the, this is the I1, I2, I3, small intervals. So what we are doing here, we are doing the algebraic sum of the all instances. So here we can say that the total area sorry, so here total area of the power divided by base. Okay, so this is how we can calculate the average value with the help of the mid-ordinate method. Okay, and second thing is that the second method, which is known as the analytical method. So basically, this method is used when the equation of AC wave is known. Okay, so for example, we have considered one equation or one waveform of current. Its equation is given by I equal to Im sine theta. Okay, so here what we have done here, let's consider an elementary strip. This one, consider an elementary strip of infinitesimal thickness of the d theta. Okay, so if I talk about the area here, area, so we can say that the area is given by of that strip is equal to dA equal to I d theta. Okay, so the area of the half cycle can be determined by area of half cycle is equal to A equal to integration of 0 to pi. We can see here this is our positive half which is starts from 0 to pi. So we are calculating the area of the positive half. So we are integrating this particular area from 0 to pi with respect to d theta. Okay, so as we know that the equation of the I is equal to Im sine theta d theta. So therefore, average value is given by I average is equal to, as we know that the area of the half wave divided by base, okay, which is equal to base is pi and the area is given by this equation. Okay, so 0 to pi Im sine theta d theta. So let's solve this equation further. So I average is equal to, now we know that the integration of sine theta is equal to minus of cos theta, and there are the limits which are 0 to pi is equal to negative of Im divided by pi, and cos pi is minus 1 minus cos 0 is 1. The equation is equal to twice of Im divided by pi. Okay, so basically in this case the value of I average is equal to twice of the maximum value divided by pi. Okay, so this is how we have calculated the average value with the help of the analytical method. Okay, so for a sine wave, this calculation is done for a sine wave. Okay, for a sine wave, so we can say that the average value I average is equal to 0.637 times of maximum value. Okay, so the basically the significance of the average value, we can say that the charge transfer capacity of an alternating current depend upon the average value. Okay, so the significance of the average value is the charge transfer capability of an alternating current depends upon its average value. Okay, so this is how we have used the analytical method and the mid-ordinate method in order to calculate the average value. Okay, so thank you very much. Kindly like and subscribe our channel.